In this unit, we're going to be stretching and shrinking two-dimensional figures, and we're going to do this by drawing wumps. Okay, so wumps are going to be explained on the next slides. So before we start with our wump family, I want to go over the coordinate plane. So this is the y-axis when you graph. The horizontal axis is the x-axis. This point at 0, 0 is called the origin. So I'm going to go through and write what each ordered pair is. We call points ordered pairs because we have an x and a y. So A is at the ordered pair 4, 5, because you go right 4, up 5. So I'm going to write A is 4, 5. B, you go left 4 and up 4. So B is going to be -4, +4. C is left 1, up 3. So -1, 3. Always write the x first, then the y. D is -1, down 2. So -1, -2. E is right 3, down 3. So right 3 is positive, down 3 is negative. And F is right 2, down 4. So you need to write ordered pairs. The first is the X and the second is the Y. Our first vocabulary term is similar figures. This is what our unit's about. Similar figures is when one shape can become another after a resize, flip, slide, or turn. So these two are similar because if you flip it over and reduce the navy blue one, you'll get the other light blue figure. These two are similar because if you enlarge A, B, C, D, you resize it, you'll get L, M, P, O. They're similar. Same shape, different size. Another vocabulary term we have is corresponding parts. So corresponding parts are points, segments, which are side lengths, and angles in the same positions. So DA, the segment, corresponds with HE, the segment. AB, the segment, corresponds with EF, the segment. So you can have segments and side lengths that correspond. You can have angles that correspond. So angle A corresponds with angle E. You can have points that correspond. So point D corresponds with point H. Notice if I talk about a point, I just use a capital letter, uppercase letter. But if I'm talking about an angle, I need to put an angle symbol in front. So if I have corresponding parts right here, angle B corresponds over here to angle E, because angle B looks like the right angle and angle E looks like the right angle. So they might not be in the exact same position. If I rotate the red figure, it will look like the blue figure. So the side AB on the red figure is the longest side that makes up the right angle. It's not the hypotenuse. This is the hypotenuse. But AB corresponds with DE. So about the Wumps, Zach and Marta's computer game involve a family called the Wumps. The members of the Wump family are various sizes, but they have the same shape. They are similar shapes. Mugwump is the main character. So here's Mug. By enlarging and reducing, so enlarge means to make bigger, reducing means to make smaller, a player can transform him into the other Wump family members, Zug, Lug, Bug, and Glug. Zach and Marta experiment with enlarging and reducing figures on a coordinate plane. So here's our Mug character. Mug is a Wump. What are the physical characteristics of a Wump? So eyes are just points. The nose is a triangle. Looks like an isosceles triangle. Two sides are equal. The mouth is a rectangle. and the legs make up squares because they're 4 right angles and 4 congruent sides. So I can actually point out what the ordered pairs are for their eyes. So the eyes are at 2, 5, and 6, 5. The nose makes up these ordered pairs. Nose has 3 ordered pairs because it's a triangle. The mouth has 4 ordered pairs because it's a rectangle. And the legs also have 4 ordered pairs. So in order to determine if Zug's a wump, it looks like Zug is a wump because we have an isosceles triangle, we have a rectangle, and we have 2 ordered pairs that are the eyes. We have squares that make up the legs. Okay, in order to see, we can formalize by looking at the corresponding parts to see if they're similar. So what I'm going to do is I'm going to write the ordered pair 8, 1 talks about this point. So over here, the corresponding lower right-hand corner is 16, 2. Okay, so can you see what the pattern is to going from 8 to 1 to 16 to 2? I don't want to stop right there. I want to check another point, at least another point that's corresponding on Mug and see how it relates to Zug. So Mug is at, this upper right-hand point is at 6, 7. It's over 6, up 7. And over here, Zug is at over 12, up 14. So can you see the pattern, what we're doing to go from 8 to 1 to 16 to 2, 6 to 7 to 12 to 14? What's the pattern? How do you go from 8 to 16? How do you go from 1 to 2? Well, the pattern is what you do is you take the x and you multiply it by 2, and you take the y and you multiply that by 2. So my rule is going to be 2x, 2y. Now, it's an enlargement because I'm going from 8 to 1 to 16 to 2. The numbers are getting greater. So that's an enlargement. You can tell it's getting bigger from Mug to Zug. So in this enlargement, and the scale factor we call is 2 because that's the number in front of our x and y, and everything is doubling. And they're similar because these two numbers have to be the same for them to be similar. If one's 2 and the other one's not 2, it's not going to be blown up, enlarged the same way. It's not going to be similar, so it's not a wump. But since they are the same number, yes, it's a wump. Let's try Lug and see if he's a wump. So a wump has to have this be similar to Mug. So let's do the ordered pair checks again. So this is 8, 1, and then the same corresponding part looks like 24, 1. So it's not good enough just to check one point. Let's check another point that corresponds. So the same part, this is at 6, 7, and then over here is at 18, let's see, it's going over 18, up 7. So what's going on from 8 to 1 to 24 to 1? What happened? Well, it looks like the x stayed the same, or x multiplied by 3, but the y stayed the same. Same goes for the other point. The x multiplied by 3 and the y stayed the same. So to write this rule, the x is multiplied by 3, so that it's 3 times wider because x goes side to side, and then the height stayed the same, the y stayed the same. So Lug is not a wump because the two numbers, the number in front of x and the number in front of y, needs to be the same. And they're not. So no, it's not a wump. Okay, let's try Bug. Is Bug a wump? So let's do the same technique. Let's compare the corresponding parts. So again, this is 8, 1, in the lower right hand corner is 24, 3. This point was 6, 7. This point is 18, 21. So can you see what the rule would be if you're going from 8 to 1 to 24 to 3? Looks like both the x and the y are changing. Are they changing by the same number? So it looks like the x is being multiplied by 3. So again, this is an enlargement, and y is being multiplied by 3. So my rule is going to be 3x, 3y. So that's an enlargement. The scale factor is 3. And yes, it is a WUMP. It's similar because the scale factors for the x and the y are the same number. Last one is GLUGA-WUMP. So let's figure out what the rule is. It looks like it's getting taller. Let's do our technique and write down the comparison. So this is 8, 1. This looks like 6, 7, 8. So this is 8, but we're going up 3. This one again is 6, 7. And then right here is over 6 up 21. So I went 8, 1 to 8, 3. Well, it looks like it's keeping the width the same. So the x is the same, so we're going to let that be x. But the y is going from 1 to 3. So it's 3y. 7 to 21 is also 3y. So you're keeping the width the same and you're tripling the height. So that you're not increasing by the same scale factor. One is 1 and the other one is 3. So no, it's not a WUMP. It's not similar.